Now, to measure the angle, right, theta, there are a few ways now. One of the common ways that they use is just using the tangent. For example, if let's say this is the diffraction grating, this is the screen, and the light enters here, then it forms an image here. So what they will do is they'll find this distance, and then so then this is the first order. So 0 order, first order. So let's say I want to find the angle for the first order. They will measure this distance, let's call this D, and then they will measure this distance, let's call this L, and then they want to find this angle theta right now. So what they will do is, once you get the image on the screen, you can easily measure this distance and this distance because it's on the screen. So then what they will do is they will use tangent theta equals to L over D to find the theta. So you can do this method. But there's a simpler way to measure the angle, which is using a spectrometer. So your spectrometer, if you've seen this in the lab, you will have this holder to put in your diffraction grating. Then this is where you'll let the light to enter. And then when the light enters the diffraction grating, remember it will be scattered first order, second order, and third. So you'll get like first order, second order, third order, and stuff like that. So you actually rotate this telescope and you find the angle. By looking through, if you can see the image, then you refer to this turntable. So there's this turntable which got angle here. So you can read the angle from there. Okay? So how do you use this? I'll show you. So what will the spectrometer show you is angle. So I teach you how to do this. So assuming the light is coming in straight here, you hit the diffraction grating, and then surely at the middle there'll be a bright image, right? The 0 order, because why? The path difference is 0. So when you put a telescope in this direction, and then you look through the telescope, you will see the image. So that will be called your 0 order, which you will ignore. And the 0 order doesn't correspond to 0 degrees, in case you're wondering, because nobody calibrates it. They don't worry. They don't care what is the reading here. And it was always not 0. Alright, so then they rotate it. As you rotate the telescope away, the image will disappear, because you only see the image at certain places, certain angles. So you keep rotating until you see the image again. So that will be the first order, because the middle is 0 order, so next one to it will be a first order. So when you see the first order, that's when you measure the angle. You read from the scale here. So let's say the angle, example, let's say the angle is 170 degrees. So don't worry, then what you do is you move it back to the middle until you see back the 0. Then you move the other side. When you move to the other side, you'll see the first order also. And now, when you get the first order, you read the angle. So now let's say the angle is 30 degrees. So it means that your 0 is somewhere. If I had to predict where the 0 is, the 0 could be somewhere here. So this is 0 degrees. That's why from here to here is 30. And from here to here is 170. So this is 170, this is 30. So what is the angle between these two? Would I take 170 minus 30? Alright, now if I want the angle from the middle, I divide by 2. So the technique is, if they give you a spectrometer reading, they will tell you the two values for between the first order and the first order, or the second order and the second order, which are like these two values. But to find the theta to substitute into the equation, you will take these two values to subtract them, and you divide by 2 to get the angle from the center. That's the only way to use a spectrometer, that's all. Okay, so you just have to know what to do with the two values. You subtract and divide by 2.